Something is hiding behind our sun right now. At this very moment, while you're watching this, an object measuring at least 5 kilometers across, roughly the width of Manhattan Island, is positioned on the opposite side of our star, completely invisible to every telescope on Earth. This isn't science fiction. This is happening today, October 21st, 2025. The object is called 3I/Atlas, and according to Harvard astrophysicist Avi Loeb, its timing might not be coincidental at all. 8 days from now, on October 29th, this massive visitor will reach perihelion, the closest point to the Sun in its trajectory. At that moment, it will receive an astonishing 33 gigawatts of power blasting onto its surface. That's the equivalent energy of 33 nuclear power plants. It's also the exact moment spacecraft engineers use for gravity assist maneuvers, the precise window when any propulsion system would fire its engines for maximum efficiency. And we won't be watching. We can't. The geometry of space has placed this object exactly where we're blind. But before it vanished behind the sun, something inexplicable happened. On October 13th, just days ago, researcher David Sereda reported detecting something that defies conventional explanation. Light pulses emanating from 3I/Atlas in a very specific pattern. Not random flickering. Not the chaotic brightness variations you'd expect from a rotating comet. A sequence. 5 flashes. Then 8. Then 13. The Fibonacci sequence, broadcast from an object traveling through our solar system at 200,000 kilometers per hour. If you're already feeling the hairs on your arms stand up, if this is making your mind race with possibilities, I need you to do something for me right now. Hit that like button. Subscribe to this channel because understanding what's happening with 3I/Atlas might be one of the most important things you learn this year. Drop a comment telling me where you're watching from, and honestly, what do you think is really out there? Is this just an unusual comet? Or are we witnessing something that could change humanity's understanding of our place in the universe? Your engagement helps this critical information reach more people, so please share this video with anyone who needs to hear this story. Now, let me tell you why October 13th matters. That date wasn't random. It marks exactly 108 years since the miracle of the sun at Fatima, Portugal. On October 13th, 1917, approximately 70,000 witnesses, including journalists and skeptics, gathered in a field after 3 shepherd children claimed the Virgin Mary told them a miracle would occur on that specific date. What happened next was documented by secular newspapers and photographed by multiple sources. Tens of thousands of people simultaneously reported seeing the sun appear to dance in the sky, spinning and plunging toward Earth before returning to its normal position. The event lasted roughly 10 minutes. Whatever occurred that day, it was witnessed by massive crowds, and it remains unexplained. Now, 108 years later to the day, Sereda reports detecting these Fibonacci pulses from an interstellar object. And 108 isn't just any number. In esoteric traditions, in ancient architectural designs, in musical tuning systems that predate modern standardization, 108 appears repeatedly. It's considered a sacred number in multiple cultures. The probability of this alignment occurring by pure chance has been calculated at less than 1%. But let's step back and look at what we're actually dealing with here. 3I/Atlas is the third confirmed interstellar object to pass through our solar system. The first was Oumuamua, discovered in 2017, a strange, elongated object that showed unexplained acceleration as it left our solar system. The second was 2I/Borisov, discovered in 2019, which appeared to be a relatively normal comet. Now we have 3I/Atlas, and this one is different in ways that are forcing mainstream astronomers to confront possibilities they've spent their careers dismissing. The object was first spotted on July 1st, 2025, by the Atlas Survey Telescope in Chile. Initially, observers weren't certain whether it was an asteroid or a comet. By early July, multiple telescopes confirmed it had a coma, a cloud of gas and dust surrounding it, indicating cometary activity. On July 2nd, the Minor Planet Center officially designated it as 3I/Atlas, confirming it as the third interstellar visitor we've detected. But the more scientists observed this object, the stranger it became. The Hubble Space Telescope captured images of 3I/Atlas on July 21st, when it was 277 million miles from Earth. Those images revealed something that shouldn't exist according to conventional comet physics. A bright extended glow pointing not away from the sun, like every normal comet tail, but toward it. Astronomers call this an anti-tail, and while they're not completely unknown, they're extremely rare and typically result from specific viewing angle illusions. But when researchers corrected for the viewing angle of 3I/Atlas, they realized this wasn't an optical trick. This was actual material being ejected toward the sun. A jet, a directed stream of gas and dust pointing sunward. Think about what that means for a moment. Comet tails point away from the sun because solar radiation and the solar wind blast material backward. That's basic physics. Material moving toward the sun is like water flowing uphill or smoke falling down instead of rising. It violates the fundamental mechanics governing how matter behaves in space. Yet here it was, documented by Hubble, confirmed by ground-based observatories, a sunward jet extending approximately 6,000 kilometers from the nucleus. Avi Loeb and his colleague Eric Kito published a paper analyzing this phenomenon. They concluded that this cannot be explained as a simple viewing angle effect. When you do the geometry properly, accounting for 3I/Atlas's position relative to Earth and the Sun, the feature remains pointed toward the Sun. That requires a physical mechanism, something actively pushing material in that direction. Natural explanations exist, perhaps large dust particles ejected slowly from a rotating hotspot positioned at one of the object's poles. But these explanations require very specific, very unlikely conditions to be met simultaneously. The sunward jet is just one anomaly. Let's talk about the chemistry because this is where things become truly bizarre. On August 24th, the Keck 2 telescope in Hawaii turned its spectrograph toward 3I/Atlas. Spectroscopy is a technique that breaks light into its component wavelengths, allowing scientists to identify what elements are present in the object's atmosphere. The data revealed something unprecedented in the history of astronomy. Prominent emission lines from neutral nickel atoms appearing without corresponding iron emissions. In every other comet ever studied, nickel and iron appear together. They're chemically bonded in the minerals that make up cometary nuclei. When these materials heat up and vaporize, nickel and iron are released together in predictable ratios. Always. Until now. The Keck data shows nickel emissions orders of magnitude stronger than typical solar system comets. Not slightly more, not twice as much, but orders of magnitude higher. And the iron that should accompany it? Absent. Not reduced. Not faint. Missing entirely. This chemical signature has one known analog, industrial nickel refining. On Earth, we use a process called the Mond process to purify nickel. You expose impure nickel to carbon monoxide gas at specific temperatures. The nickel reacts with the carbon monoxide to form nickel tetracarbonyl, which can be separated from contaminants. Then you heat it up, and it decomposes back into pure nickel and carbon monoxide. This industrial process is how humans refine nickel. It's technology we invented. It doesn't occur naturally because nature doesn't provide the precise temperature, pressure, and atmospheric conditions required to make it happen consistently. Yet spectroscopic analysis of 3I/Atlas shows nickel emissions consistent with carbonyl decomposition, appearing without iron contamination. The research paper documenting this finding states explicitly that other than 3I/Atlas, this anomaly of nickel without iron was previously only known to exist in industrially produced nickel alloys. Not in comets. Not in asteroids, not in any natural celestial body, in human-made materials, and now apparently in an object that traveled here from another star system. Before you dismiss this as coincidence, before you assume there must be some natural process we simply don't understand yet, consider the third major anomaly, the object's mass. When a comet releases gas and dust, physics demands a reaction. The escaping material carries momentum. That momentum has to come from somewhere. It comes from the comet itself. The comet gets pushed in the opposite direction of the outflow, like a balloon releasing air. Astronomers call this non-gravitational acceleration. Over weeks and months, a venting comet will drift slightly off the trajectory predicted by gravity alone. Avi Loeb examined orbital data for 3I/Atlas spanning from May through September 2025. During that entire period, the object was actively outgassing. The James Webb Space Telescope confirmed carbon dioxide sublimating from the surface at a rate of 150 kilograms per second with an outflow velocity of 440 meters per second. That's significant mass loss generating substantial thrust. The object should be deviating from a purely gravitational path. But it wasn't. The measured positions matched gravitational predictions within error margins. No detectable non-gravitational acceleration despite months of vigorous outgassing. There's only one explanation. The object is so massive that the thrust is negligible. The force is real, but the acceleration is too small to measure because mass is in the denominator of the equation. Loeb did the calculation, taking the upper limit on position deviation and the known thrust from outgassing. He determined that 3I/Atlas must weigh at least 33 billion tons. 33 billion tons. If you assume this is solid ice at typical cometary density, you need a sphere roughly 5 kilometers in diameter to contain that much mass. 5 kilometers. That's the width of Manhattan Island. The first interstellar object, Oumuamua, was estimated at maybe 100 to 200 meters. 2I/Borisov was perhaps a kilometer. 3I/Atlas is at minimum 5 kilometers across, possibly much larger, potentially up to 46 kilometers based on brightness measurements from the Spitzer Space Telescope. It's orders of magnitude more massive than any previous interstellar visitor. And it's moving through our solar system on a trajectory that, statistically speaking, it should not have. Let me explain the trajectory problem, because this is where coincidences start stacking to uncomfortable heights. Interstellar space is three-dimensional. Objects ejected from other star systems can approach our solar system from any direction. Up, down, sideways, any angle relative to the plane where our planets orbit. If interstellar visitors arrive randomly, most should come in at steep angles, diving through well above or below the planetary disk. The probability of any given object arriving nearly flat, within just a few degrees of the ecliptic plane, is very small. 3I/Atlas arrived within 5 degrees of the ecliptic. Loeb calculated the probability of this occurring by random chance, approximately 0.2%. 1 in 500. Now, 1 in 500 sounds unlikely, but not impossible. Rare things happen. But here's where it gets interesting. 3I/Atlas didn't just arrive flat. It arrived flat at exactly the right moment to pass near multiple planets due to its retrograde motion, moving opposite to the direction planets orbit. The object passed within 30 million kilometers of Mars on October 3rd. It will pass similar distances from Venus and Jupiter in the coming months. These close encounters aren't accidents of trajectory. They're built into the orbital mechanics of something arriving flat and retrograde at this specific time. Loeb calculated the probability of this timing, not just arriving flat, but arriving at the right moment for these planetary encounters, at 0.005%. 5 in 100,000. And there's more. The arrival direction of 3I/Atlas aligns within 9 degrees of the direction from which the famous WOW signal was detected in 1977. For those unfamiliar, the WOW signal was a powerful narrowband radio transmission detected by Ohio State University's Big Ear Telescope on August 15, 1977. Astronomer Jerry Emmons saw it in the data printout and wrote, "Wow," in the margin, giving the signal its name. The transmission lasted 72 seconds and was never detected again despite repeated searches. Its origin remains unexplained. 3I/Atlas came from the same region of the sky, the constellation Sagittarius. The angular separation between the two directions is approximately 9 degrees. The probability of an interstellar object arriving from within 9 degrees of a specific randomly chosen direction is about 0.6%. 1 in 167. Now we're stacking improbabilities. Flat trajectory, 1 in 500. Timed arrival for planetary encounters, 1 in 20,000. Arrival direction matching the wow signal, 1 in 167. Even accounting for the fact that some of these probabilities are correlated, you're looking at combined odds well below 1 in a million. At what point does coincidence become implausible? At what point do we acknowledge that random chance isn't a satisfying explanation for a cluster of low-probability features occurring simultaneously in the same object? Critics would argue we're suffering from selection bias. We notice improbable features because they're interesting. We don't notice all the unremarkable interstellar objects passing through undetected. Finding one unusual object isn't surprising if thousands pass through every year. Detection bias is real, yes. But detection bias explains why we might find an object with one unusual feature. It doesn't easily explain why the object we found has 8 anomalies occurring together. Let me walk you through all 8, because you need to see the complete picture. Anomaly 1, trajectory alignment. Less than 1% probability of arriving flat in the ecliptic plane at the right time for multiple planetary encounters from a direction matching the wow signal. Anomaly 2, the sunward jet. Material ejected toward the sun in a stable, collimated stream that persists despite the nucleus rotating every 16 hours. Anomaly 3, nickel without iron. Chemical emissions matching industrial refining processes, unprecedented in natural objects. Anomaly 4, extreme mass. At least 33 billion tons, requiring a diameter of at least 5 kilometers, orders of magnitude larger than other interstellar visitors. Anomaly 5, negative polarization. Light scattered from 3I/Atlas shows polarization in the opposite direction from every known comet, indicating unusual particle properties no one can adequately explain. Anomaly 6, water depletion. The gas plume is dominated by carbon dioxide with only about 4% water, a complete inversion of typical cometary composition. Anomaly 7, cyanide concentration. Emissions orders of magnitude higher than normal comets, suggesting organic-rich material that somehow exists without the water that typically accompanies such chemistry. Anomaly 8, rotation period relationships. The measured rotation period of 16.16 hours converts to 969.6 minutes, which according to David Serrata's analysis produces golden ratio relationships when divided by Earth's sidereal period. This 8th anomaly ventures into numerology and is the most speculative, but the first 7 are documented observational facts published in peer-reviewed papers. Each anomaly individually might have a natural explanation requiring specific, unlikely conditions. But all 8 together? That's not just unlikely. That's a pattern-demanding explanation beyond hand-waving about weird comets and unusual circumstances. When you need multiple low-probability factors to align simultaneously to maintain the natural explanation, you have to ask whether you're explaining the data or explaining it away. Now, here's what makes this moment critical. Right now, as you're watching this, 3I/Atlas is experiencing solar conjunction. It's directly behind the sun from Earth's perspective. Ground-based telescopes can't observe it without pointing at the sun, which would destroy their instruments. Space telescopes face the same limitation. The geometry simply doesn't allow observation. For at least the next week, possibly longer, we're completely blind to what's happening with this object. And this isn't random bad timing. This is determined by the orbit, by the trajectory, by the arrival date. When you look at the sky today during daytime, the sun is there. Behind it, hidden from view, moving toward its closest approach to that sun, is an object exhibiting multiple characteristics that violate our assumptions about interstellar visitors. And we cannot see it. We cannot track it. We cannot monitor what happens during this critical window. What happens next matters. On October 29th, 8 days from today, 3I/Atlas reaches perihelion, minimum distance from the sun, approximately 130 million miles. That's just inside Mars' orbit. Not particularly close in absolute terms. The sun won't melt or tear it apart. But perihelion is important for 2 reasons. First, It's the point of maximum energy input. Sunlight intensity follows an inverse square law. At perihelion, 3I/Atlas receives more solar energy per square meter than at any other point in its journey. If it's a comet, outgassing should peak. If it's something else, energy-intensive operations become feasible. Second, perihelion is critical because of the Oberth effect, a consequence of orbital mechanics every spacecraft designer knows intimately. If you want to change velocity, the most efficient place to do it is deep in a gravity well where you're moving fastest. A small thrust applied at high velocity produces a larger change in orbital energy than the same thrust farther out. This is why planetary flyby missions use gravity assists at closest approach. This is why any mission designed to maximize efficiency would time propulsive maneuvers for perihelion. If 3I/Atlas wanted to change course, if it had any capability to do so, now would be the time. 8 days from now, at the moment of closest approach when it's moving at maximum speed through the sun's gravity well, a velocity change of just a few kilometers per second could redirect it toward a specific target. And we won't be watching. The object will be behind the sun. We won't see any maneuver if it happens. We'll only know afterward when 3I/Atlas emerges in November and we recalculate its trajectory. This brings us to the observation that has everyone talking, the one that sounds like science fiction but is being taken seriously by researchers worldwide. On October 13th, David Sereda was monitoring 3I/Atlas through multiple channels when he detected what he describes as structured light emissions. Not gradual brightening and dimming from rotation. Not chaotic fluctuations from outgassing. A pattern. 5 pulses of increased luminosity. Then 8. Then 13. The sequence repeated. Sereda, who has collaborated with MIT physicist Bogdan Maglich on nuclear fusion research, immediately recognized what he was seeing, the Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. Each number is the sum of the two before it. This mathematical pattern appears throughout nature, in nautilus shell spirals, in sunflower seed arrangements, in galaxy structures. It generates the golden ratio, phi, approximately 1.618, a proportion that seems woven into reality's fabric. Now here's where this becomes unsettling. October 13th, 2025 marks exactly 108 years after the Fatima miracle. And 108 is not random. It's a frequency octave of 432, a number appearing repeatedly in ancient temple dimensions and musical tuning systems predating modern standards. Sereda claims he was told in a vision to add 432 days to October 19th, 2024. The result? December 25th, 2025, Christmas Day. The same day his calculations show 3I/Atlas reaching closest approach to Earth while achieving what he calls the Great Pyramid Angle, a specific geometric relationship encoded in the Giza Pyramid slope. I know how this sounds. Visions, Fatima miracles, ancient pyramids, Fibonacci codes from interstellar objects. Every rational impulse screams, this is pattern-seeking, numerology, the human brain desperate to find meaning in randomness. And maybe it is. But here's what we cannot ignore. The light pulse observations, according to Sereda, occurred. He published data. The timing is verifiable. October 13th, 2025, exactly 108 years after Fatima. The trajectory calculations are verifiable. 3I/Atlas will indeed be at closest approach to Earth on December 25th. The geometric alignment he describes can be calculated and checked. The question isn't whether Sereda is fabricating things. The question is whether what he observed is real, and if real, whether it means what he thinks it means. And here's where timing becomes uncomfortable. On October 13th, the same day Sereda reported these observations, NASA's Solar Dynamics Observatory experienced what the agency described as technical difficulties and stopped providing public data feeds. The spacecraft monitors the sun continuously, producing images normally available to the public in near real time. That feed went dark on October 13th. It has since returned, But the gap exists during the precise window when Sareda claims to have observed the Fibonacci pulses. Could this be coincidence? Of course. Technical malfunctions happen. But the timing raises questions, especially considering what happened next. On October 1st, just 2 days before 3I/Atlas made its closest approach to Mars, offering the best observation opportunity we'll have until it passes Jupiter in 2026, the United States government shut down. NASA furloughed more than 15,000 employees, 83% of its workforce. Only personnel deemed essential remained. The agency's website stopped updating, and the high-rise camera aboard the Mars Reconnaissance Orbiter, positioned to capture images with 30 km per pixel resolution, the highest resolution images ever possible of this object. Those images have not been released to the public. The European Space Agency released some images from Mars orbiters on October 7th, for days after the flyby. They show 3I/Atlas as a fuzzy blob, qualitatively similar to what Hubble captured months earlier, but from much closer range. Interesting, but they don't provide the detail HiRISE should have captured. And NASA has said nothing. Representative Anna Paulina Luna publicly asked about the HiRISE images. White House Deputy Chief of Staff Stephen Miller was asked whether the president had been briefed on 3I/Atlas. The question was deflected. Avi Loeb has repeatedly mentioned that the HiRISE images would answer critical questions about this object's size and nature. But as of today, those images remain unreleased. So we have Fibonacci pulses reported on October 13th, NASA's Solar Dynamics Observatory going dark the same day. The government shut down beginning 2 days before the critical Mars flyby. HiRISE images withheld. And Sareda connecting all of this to a prophetic timeline, pointing to Christmas Day as some culmination point. It would be easy to dismiss this as conspiracy thinking if not for one uncomfortable fact. The other anomalies are not speculation. They're documented, peer-reviewed, forcing mainstream astronomers into intellectual contortions to explain them away. And the pattern keeps emerging. Different researchers using different methods arriving at similar conclusions. Sareda talks about Fibonacci codes and sacred geometry. Loeb talks about orbital mechanics and Oberth maneuvers. Both point to late December as a critical period. Coincidence or convergence? When different analytical approaches reach similar timelines, either the pattern is real or we're all fooling ourselves in similar ways. The next 70 days will tell us which. Let me be very clear about something. I'm not claiming 3I/Atlas is definitely artificial. I'm not saying aliens. I'm not declaring this as first contact. What I'm saying is that we have an object exhibiting 8 distinct anomalies, each individually unusual, collectively unprecedented. We have trajectory alignments calculated at less than 1% probability. We have chemical signatures never observed in nature matching industrial processes. We have mass estimates placing it in a category that shouldn't exist for interstellar wanderers. We have timing that strains credulity, arriving during optimal observation windows, vanishing behind the sun during perihelion, potentially re-emerging with trajectory changes we won't be able to verify without baseline data still being withheld by NASA. At what point do we acknowledge this deserves serious investigation without dismissing uncomfortable possibilities out of hand? Avi Loeb developed a ranking system for assessing anomalous objects. 0 means definitely natural. 10 means definitely artificial. Most objects score 0. A few might reach 1 or 2 with minor oddities. Loeb ranks 3I/Atlas as a 4. That's high. That means genuinely anomalous, but not conclusive. It means this object exhibits multiple features not fitting neatly into our understanding of natural comets, but not so extreme we must abandon natural explanations entirely. Not yet. The comparison to Oumuamua is instructive. That first interstellar visitor also had anomalies, elongated shape, unusual acceleration. Loeb argued it might be a light sail. Most astronomers argued it was a comet with weird outgassing. Debate raged for years. Eventually, modeling showed outgassing from specific vents could explain the acceleration. The natural explanation won, though some still argue the case isn't closed. 3I/Atlas is heading down a similar path. Anomalies documented. Natural explanations proposed. Debate intensifying. Will it end the same way? Maybe. But 3I/Atlas has more anomalies than Oumuamua. The chemistry, the mass, the trajectory, the timing, all piling on top of geometric and physical oddities. Explaining this naturally requires more special pleading, more unlikely coincidences, more just-so stories. And that makes the natural explanation less satisfying even if it remains most likely. Think about what we're discussing. We have an object confirmed to have originated beyond our solar system, traveling on a trajectory multiple scientists calculate has less than 1% probability of occurring by chance. This object is currently hidden directly behind the Sun, unreachable during the exact period when it reaches perihelion, and would have maximum energy available for any maneuver or activity. It will remain hidden until early November. When it emerges, we'll see if its trajectory changed. We'll see if it fragmented, releasing smaller objects. We'll see if it's still behaving like a comet or if something else is happening. And if Sarada is even partially correct, if there's any validity to the December 25th timeline, we have 65 days to watch this object as it moves from perihelion back through the solar system. 65 days to see if the pattern holds, if the Fibonacci message was real, if the timing is prophetic or merely the latest apocalyptic prediction amounting to nothing. But here's what keeps people awake. We have those 65 days to watch, but only if NASA releases data, only if high-rise images are made public, only if the global astronomical community can coordinate observations when 3I/Atlas emerges from behind the Sun in November. And right now, during the most critical observation window we've had, during the exact week when this object is at perihelion receiving maximum solar energy, NASA is withholding the best images and the object is invisible to us. Coincidence? Maybe. But when coincidences stack this high, when timing aligns this precisely, when patterns fit this neatly, the word coincidence starts feeling inadequate. It starts feeling like something we say when we don't want to confront other possibilities. And those other possibilities, the ones we'll explore as this object story unfolds, those aren't comfortable. They're not safe. They challenge everything we think we know about our place in the cosmos, about whether we're alone, about whether we're being observed, studied, perhaps even contacted by something understanding mathematics and geometry in ways making our most advanced physics look primitive. If you've made it this far, you understand this isn't just another space story. This is potentially one of the most significant astronomical events in human history unfolding in real time. Drop a comment right now telling me what you think. Are we looking at a weird comet or something more? And make sure you've hit that like button because engagement on this video determines how many people learn about what's happening. Share this with anyone who should know. We need as many eyes on this as possible. November will be critical. When 3I/Atlas emerges from behind the Sun, multiple observatories will reacquire it. The first observations will focus on position. Where is it compared to where gravity predicts it should be? Orbital mechanics are deterministic. Given position, velocity, and gravitational forces, you can calculate future position with high precision. Before going behind the Sun, we knew its orbit. When it reappears, we'll measure again. If new positions match gravitational predictions, nothing unusual occurred. The object coasted through perihelion following Newton's laws. No surprises. But if positions don't match, if there's any discrepancy beyond measurement error, that indicates a force acted during the hidden period. Non-gravitational forces from outgassing can produce this. But conditions at perihelion are different. Heating is intense. Even a massive object might show detectable acceleration if outgassing is strong and asymmetric enough. So finding trajectory change wouldn't immediately prove anything artificial. It would just confirm forces beyond gravity are at play. But the nature of any change matters. If 3I/Atlas drifted slightly off course in a random direction, that looks like outgassing. If it shifted in a specific direction, if the new trajectory points toward a particular target, that looks different. That looks like a course correction. Distinguishing these scenarios requires careful analysis. You need multiple position measurements to determine velocity accurately. You need to model expected outgassing forces based on surface temperature and rotation. You need comparing observed acceleration to model predictions. This takes time, weeks, possibly months. By then we'll be well into December, approaching the timeline both Sarita and Loeb identified as potentially significant. The European Space Agency's JUICE spacecraft will pass within 64 million kilometers of 3I/Atlas on November 4th. The spacecraft, en route to study Jupiter's icy moons, carries cameras, spectrometers, and magnetometers. It will observe from a different angle than Earth-based telescopes, providing a second viewpoint for triangulation. If 3I/Atlas fragmented, if multiple objects now exist where there was one, JUICE might resolve them separately. If the object shows unusual activity, jets, flares, anything beyond normal cometary behavior, JUICE's instruments should detect it. Data will take time to process, but by mid-November we should have preliminary reports. This matters because JUICE is an active mission with full operational support. Unlike NASA during the shutdown, ESA has been forthcoming with releases. If JUICE observes something truly anomalous, we'll likely hear relatively quickly. December 19th, 3I/Atlas reaches closest approach to Earth, 269 million kilometers, about 1.8 astronomical units. Not particularly close. Farther than Mars at its nearest, but close enough for detailed observation. Large ground-based telescopes, space telescopes, even amateur astronomers with good equipment will be able to track it. Viewing geometry will be favorable. The object will be well-placed, visible for extended periods, allowing multiple observations nightly. This is when we see it at its best. If the nucleus is large, we might get size estimates from brightness measurements alone. If still outgassing, spectroscopy will reveal plume composition. If fragmented, we'll see multiple objects spread along the orbit. If it released anything, mini probes, debris, whatever, those objects will have had 2 months to separate. By December, they should be far enough apart to resolve individually if bright enough, and if anyone's looking carefully. Sarita's timeline points to December 25th, Christmas Day. He claims this is when 3I/Atlas reaches the Great Pyramid angle relative to Earth. The geometry is calculable. If you know positions on December 25th, you can compute the angle between them from a reference point. Whether that matches the Giza pyramid slope is arithmetic. Sarita could be right or wrong, but the claim is testable. On Christmas Day, someone with orbital tools can check. If the angle matches, that's interesting coincidence. If it doesn't, Sarita's prediction fails, and the Fibonacci interpretation becomes less credible. But even if the pyramid angle is wrong, the date remains significant because of Oberth maneuver physics. Objects released from 3I/Atlas at perihelion, October 29th, would take roughly 60 days to reach Earth if given initial velocity of 30 to 40 kilometers per second. 60 days from October 29th is late December. Christmas falls well within that arrival window. So even without Sarita's esoteric geometry, December 25th is worth watching simply because physics puts it in the arrival corridor for hypothetical probes. And then there's March 2026. NASA's Juno spacecraft, currently orbiting Jupiter, will observe 3I/Atlas when it passes within 54 million kilometers of the gas giant on March 16th. Juno carries infrared spectrometers, cameras, and radio instruments. At that distance, it should capture detailed data about composition, temperature distribution, and structure. This observation happens after perihelion, after any potential trajectory changes, after December's closest approach to Earth. By March, we'll know if 3I/Atlas behaved as expected or if something unusual occurred. Juno's data will provide context for everything observed earlier. If the object shows signs of artificial origin, Juno might detect thermal signatures inconsistent with natural bodies, hot spots in unexpected locations, stable temperature anomalies not correlating with solar illumination. These signatures would be subtle but detectable if you know what to look for. So the observation timeline stretches from November 2025 through March 2026. 5 months of watching. 5 months of data collection. 5 months to determine if 3I/Atlas is what it appears to be or something else entirely. And through all of it, the awareness that we're operating on incomplete information. We still don't have high-rise images. We still don't know true size. We still don't have definitive explanations for chemical anomalies. We're watching something we don't fully understand, trying to predict what it will do next, hoping we recognize signs if something unusual happens. The emergence in November will tell us if trajectory changed. December will tell us if anything approaches Earth. March will give us Juno data. By next spring, we should have enough information to close the book on 3I/Atlas, to say definitively whether this was a fascinating but natural comet or the beginning of something much larger. Let me address the elephant in the room, the possibility this is artificial. What if 3I/Atlas isn't a comet? What if it's a probe, a spacecraft, something deliberately sent to explore our solar system? The implications cascade rapidly into uncharted territory. First would come confirmation. Multiple observatories would need verifying the object's nature and behavior. You can't declare first contact based on single anomalous data. Independent confirmation is essential. Second, characterization. What is it? How big? What's it made of? Is it transmitting? Maneuvering? You gather maximum data using every available instrument. Third, classification. Is it a probe, a derelict, a functioning spacecraft, an automated system? These distinctions matter. A probe suggests deliberate exploration, intelligence with intent. A derelict suggests past intelligence, but no current threat. An active spacecraft suggests current intelligence and potential for interaction or conflict. Fourth, communication attempts. Do we try signaling it? Attempt contact? Or stay quiet and observe? The decision depends on classification and philosophical questions about whether revealing our presence is wise. If 3I/Atlas is a probe heading for Earth, it already knows we're here. Attempting contact might provoke response we're not ready for. If it's automated, programmed for specific mission, it might not respond to our signals. If it's controlled by intelligence elsewhere, response time could be years depending on controlling entity distance. All this assumes the object is willing and able to communicate with us, a huge assumption. The other possibility is defense. If something approaches Earth and we determine it's a threat, what do? We have no space defense infrastructure. We can intercept ballistic missiles moving at few kilometers per second in predictable trajectories. An object from deep space would be moving at tens of kilometers per second on trajectories we might not understand until too late. Intercepting would require launching something to match trajectories, taking time we might not have. Nuclear weapons could theoretically be used. Launch a missile, detonate near the object, try deflecting or destroying it. But nukes in space are problematic. They don't work like an atmosphere. No shockwave, just radiation and kinetic debris. You'd need multiple warheads carefully timed to affect a solid object. And if the object is large, as 3I/Atlas appears, nukes might not do much. You'd fragment it at best, creating multiple smaller threats instead of one large one. The honest answer? We're not ready. If something artificial is approaching Earth right now, we have no good options. We can observe, analyze, attempt communication, but we cannot effectively intercept, defend, or control the situation. We're passengers watching events unfold, hoping whatever's coming is benign or at least indifferent to us. That's an uncomfortable realization, a level of helplessness most people don't like contemplating. Avi Loeb suggested that discovering extraterrestrial technology, even just a derelict probe, would reset human priorities. We'd stop fighting over borders and resources and ideologies if we realized we're not alone, not the pinnacle of intelligence, latecomers to a cosmos already populated by others. Petty conflicts dominating human history would seem trivial compared to larger context. We'd unite out of necessity, if not idealism, to face implications together. This is optimistic. History suggests humans are good at finding reasons to fight, even when external threats loom. But maybe, just maybe, the shock of confirmed contact would jar us from usual patterns. Maybe realizing we're being visited, studied, evaluated by something with technology beyond ours would inspire cooperation rather than competition. Maybe we'd rise to the occasion. Or maybe we'd fracture. Different nations claiming different interpretations. Religious groups declaring it divine or demonic. Conspiracy theorists blaming governments for hiding truth. Panic as people realize assumptions about reality are wrong. Markets crashing as investors flee to safety. It could go very badly very quickly. And preventing that, managing revelation, minimizing chaos, requires preparation we haven't done. So we sit here in October 2025 watching an object hide behind the sun, wondering what happens next, hoping it's nothing, preparing for possibility it's something. Knowing either way the next few months will tell us whether we live in a universe where we're alone or one where we have neighbors. And if we have neighbors, whether those neighbors are friendly, hostile, or utterly indifferent to the small blue planet they're passing on their way elsewhere. Let's talk about what makes this object so statistically improbable it demands attention. The size alone is extraordinary. Based on the lack of non-gravitational acceleration despite vigorous outgassing, Loeb calculated minimum mass at 33 billion tons. Assuming typical cometary density, that requires diameter of at least 5 kilometers. For comparison, Oumuamua was estimated at 100 to 200 meters. 2I/Borisov perhaps a kilometer. 3I/Atlas is 5 to 50 times larger than previous interstellar visitors. This matters because size distribution of interstellar objects follows a power law. For every giant comet, there are thousands of small ones. Probability of detecting a small versus giant object depends on brightness scaling with surface area, scaling with radius squared. A 5-kilometer object has 25 times the surface area of 1-kilometer object, reflecting 25 times more sunlight, making it easier to detect at given distance. But that doesn't overcome rarity. There are so many more small objects that even accounting for detection bias, you expect finding small ones first. We found Oumuamua first, small, dim, fast-moving, barely caught leaving. We found Borisov second, medium-sized, clearly active comet. Both fit expectations. Then we found 3I/Atlas, massive, bright, arriving on trajectory that should be vanishingly rare. If you assume interstellar objects arrive randomly from galactic reservoir of ejected planetesimals, finding a 5-kilometer giant as only your third detection is strange. Numbers don't add up well. Loeb argues that 3I/Atlas, if confirmed this massive, represents statistical anomaly demanding explanation. Either the interstellar population of large objects is much higher than models predict, or 3I/Atlas isn't a random sample from that population. If not random, what is it? A deliberately sent object? A rare survivor from early planetary formation? A fragment of something larger that broke apart in interstellar space? Each scenario has problems. Each requires special pleading. The high-rise images would resolve this. Camera resolution at Mars flyby distance translates to 30 kilometers per pixel. The brightest pixel would tell nucleus size directly. If nucleus occupies 1 pixel saturated bright white, it's at least 30 kilometers across. Enormous, far larger than 5-kilometer minimum, so anomalous natural origins become almost untenable. If nucleus occupies 1 pixel not saturated, you estimate area from brightness assuming albedo value. If occupying multiple pixels, you measure directly. Any outcome would constrain size tightly. But we don't have those images. We don't know if they show 1 pixel bright dot, multi-pixel extended source, or something else entirely. We're left with indirect constraints. Mass must be at least 33 billion tons. Diameter at least 5 kilometers, possibly up to 46 kilometers based on Spitzer brightness measurements assuming 4% albedo typical for comets. True size is somewhere in that range. 5 kilometers is already anomalous. 46 is absurd. If 3I/Atlas is toward the upper end, if it's tens of kilometers across, it's not just large. It's in a different category entirely. Objects that size aren't comets. They're dwarf planets. Large enough to have experienced significant internal evolution, differentiation, possibly melting, and reformation. and they're not supposed to be wandering interstellar space at hyperbolic velocities. Think about how objects get ejected from star systems. Planets form from gas and dust disks around young stars. Most material ends up in planets or gets blown away by stellar wind. A small fraction, icy bodies in outer regions, remains loosely bound. These are comets, asteroids, Kuiper belt objects. Occasionally, gravitational interactions with giant planets kick some onto escape trajectories. They leave and drift through the galaxy. This ejection process favors smaller objects. Close encounter with a planet easily flings kilometer-sized comet into interstellar space. Flinging 5-kilometer object requires more energy. Flinging 46-kilometer object requires very specific, violent interaction. The larger the object, the less likely clean ejection. Instead of being thrown out, it's more likely perturbed into different orbit within system, shattered by tidal forces, or captured by planet. Getting truly large object, tens of kilometers across, ejected intact at high velocity is difficult. Not impossible, but difficult enough they should be rare in interstellar population. And yet here we apparently are looking at one. Loeb noted that if high rise confirms diameter significantly larger than 5 kilometers, natural origin hypothesis faces serious trouble. Statistical improbability combined with trajectory alignment and chemical anomalies would stack enough coincidences that artificial origin would need serious consideration. Not as only explanation, but as hypothesis worthy of rigorous investigation rather than reflexive dismissal. The mass also relates to the sunward jet. Massive objects need more force to accelerate noticeably. If 3I/Atlas is truly 33 billion tons, outgassing would need to be extraordinarily powerful to produce measurable trajectory changes. The fact we see no non-gravitational acceleration despite active outgassing tells us either the object is incredibly massive or the outgassing is symmetrical enough that thrust vectors cancel out, or both. But here's where the sunward jet complicates things. Asymmetric venting creates net thrust. A jet pointing toward the sun pushes the object away from the sun. Over months, that should produce detectable acceleration in the antisolar direction. We don't see it. This suggests either the sunward jet is weaker than it appears, or there are other jets pointing different directions canceling the effect, or the mass is so enormous the acceleration is below detection limits even with strong asymmetric venting. Each explanation is plausible. Each requires specific conditions. And when you need multiple specific conditions simultaneously, you're in territory where natural explanations start straining. Not impossible, just increasingly elaborate. The water depletion adds another layer. When James Webb Space Telescope analyzed 3I/Atlas's coma on August 6th, it found the gas mixture dominated by carbon dioxide. Water vapor was present but constituted only about 4% of detected molecules. This is backwards. Solar system comets typically show water as the dominant volatile, with carbon dioxide, carbon monoxide, and other species as minor constituents. The ratio varies. Some comets are wetter, some drier, but water usually dominates because water ice is the primary component of cometary nuclei. They're called dirty snowballs for a reason. They're mostly water ice mixed with dust and frozen gases. When heated, water sublimates first and most abundantly. 3I/Atlas shows the opposite pattern. Carbon dioxide dominates. Water is the minor species. That suggests a nucleus unusually rich in carbon dioxide ice relative to water ice, which is chemically strange. Where do you get a comet forming with that composition? In our solar system, water ice condenses readily in the cold outer regions where comets form. Carbon dioxide ice can also form, but typically in smaller amounts. Getting a comet dominated by carbon dioxide requires forming in an environment depleted in water or enriched in carbon dioxide beyond typical ratios. Maybe the star system 3I/Atlas came from had unusual chemistry. Maybe the protoplanetary disk was water-poor and carbon-rich. Possible, but uncommon. Most stars form planets from similar elemental abundances. Heavy water depletion requires specific formation conditions. Alternative explanation, 3I/Atlas started with normal water content, but has been losing water preferentially during its journey through interstellar space. If the object spent millions of years exposed to cosmic rays and interstellar radiation, surface ice could sublimate slowly even in deep cold. Water, being lighter and more volatile than carbon dioxide, might escape preferentially, leaving a carbon dioxide-rich residue. By the time the object reached our solar system, surface layers would be depleted in water, showing the inverted ratio we observe. This scenario is plausible, but requires long exposure time and specific thermal history. And it doesn't explain the extreme nickel emissions. Nickel doesn't sublimate from ice. It comes from rocky or metallic components in the nucleus. The fact we see strong nickel without corresponding iron suggests the metallic fraction of 3I/Atlas has unusual composition, either naturally weird or artificially refined. The negative polarization mystery compounds things. Light scattering off dust particles produces polarization, oscillations preferentially oriented perpendicular to scattering plane. Comet dust typically shows positive polarization. Light scattered at right angles is polarized perpendicular to the plane containing incident light, scattered light, and scattering particle. Every known comet shows this pattern. 3I/Atlas shows negative polarization. Light polarized parallel to the scattering plane rather than perpendicular. This happens when particles are very small, comparable to light wavelength, or have unusual optical properties like high refractive index or specific shapes. Researchers modeling this concluded that 3I/Atlas's dust must have particle size distribution or composition radically different from typical comets. Maybe particles are submicron size, maybe they're metallic, maybe they're fractal aggregates with weird scattering geometry. Each possibility is exotic. None fits neatly into standard cometary dust models. And this brings us back to the nickel anomaly. If dust is metallic, if nickel-rich particles dominate the coma, that could explain negative polarization. Metallic particles scatter light differently than silicate or carbonaceous dust. They could produce the observed polarization reversal. But metallic dust from comets is extremely rare. Comets are ice and rock, not metal. They contain trace metals mixed into rocky material, but not enough to dominate the dust population. Finding metallic dust requires either an object unusually rich in metals, which contradicts the idea of a comet, or an object releasing metals through some process not involving normalized sublimation. That process could be industrial refining, as suggested by the nickel without iron signature. Or it could be something else, some natural mechanism we haven't thought of yet. The cyanide concentration adds organic complexity. Spectroscopic observations detected hydrogen cyanide emissions from 3I/Atlas at levels orders of magnitude higher than typical comets. Cyanide is interesting because it's a building block for organic molecules. It reacts with water under the right conditions to form amino acids and other prebiotic compounds. High cyanide concentrations suggest the nucleus is organically rich, containing carbon-nitrogen compounds that could potentially seed life on planets they contact. This is exciting from an astrobiology perspective. Interstellar comets might carry organic chemistry between star systems, delivering the chemical ingredients for life to planets that wouldn't develop them independently. If 3I/Atlas is extraordinarily rich in organics, it represents a potential vector for panspermia. The idea that life spreads through the cosmos via comets, asteroids, and interstellar travelers carrying biological precursors or even dormant microbes. But here's the puzzle. High cyanide usually correlates with high water because cyanide chemistry requires water ice as a substrate during formation. 3I/Atlas shows high cyanide and low water simultaneously. That's chemically odd. You need water to make the organic compounds generating cyanide emissions, but the object is depleted in water. Either it formed with water and lost most of it, retaining organics formed earlier, or it formed through different chemistry than we're used to. Each explanation requires special circumstances. Each makes the object unusual. When you compile all 8 anomalies into a single picture, you get an object that violates expectations in multiple independent ways. Trajectory is improbable. Size is anomalous. Mass resists explanation. Chemistry is unprecedented. Dust properties are reversed. Organics are extreme. And timing places all this in our observation window during an era when we're finally capable of detecting and studying interstellar visitors. The timing itself might be selection bias. We notice the anomalies because we're looking now. A century ago, 3I/Atlas would pass unnoticed. A century hence, maybe such objects will be common. But from our perspective, in 2025, this feels significant. It feels like the universe is showing us something we need to see, something challenging our assumptions, forcing us to expand our understanding or acknowledge possibilities we've dismissed. Avi Loeb has been vocal about scientific conservatism stifling progress. The academic community, he argues, defaults to conventional explanations even when those explanations require increasingly elaborate assumptions. Natural origins become intellectual comfort zones. Suggesting artificial origins invites ridicule, damages reputations, gets you dismissed as fringe. So scientists self-censor, proposing only hypotheses that won't generate controversy, avoiding ideas that could be career-ending if wrong. This conservatism is understandable. Science is a reputation-based enterprise. Your credibility determines whether colleagues take your work seriously, whether journals publish your papers, whether grants get funded. One major mistake, one high-profile claim that turns out wrong, can permanently damage your standing. So researchers play it safe. They propose testable natural explanations. They wait for overwhelming evidence before entertaining exotic possibilities. They let others take risks while they publish careful, conventional work that advances the field incrementally without making waves. Loeb argues this approach is too slow. We're in an era where interstellar visitors are being detected regularly. Atlas survey telescopes, Pan-STARRS, upcoming Vera Rubin Observatory. These systems will find dozens, maybe hundreds of interstellar objects over the next decades. Each one is an opportunity to learn about conditions in other star systems, about planetary formation elsewhere, about whether we're alone. If we default to assuming everything is natural, if we never seriously investigate the possibility of artificial origin, we might miss first contact simply because we weren't willing to look. The Galileo project, which Loeb leads, is designed to address this. It's an initiative using advanced telescopes, cameras, and analysis tools to search for evidence of extraterrestrial technology. Not just radio signals or optical transmissions, but physical objects, probes, spacecraft, debris, anything indicating intelligence beyond Earth. The project takes a data-driven approach. Collect observations. Analyze them. If you find something anomalous, investigate rigorously. Don't assume it's natural. Don't assume it's artificial. Determine what it is based on evidence, following where data leads even if that means confronting uncomfortable conclusions. 3I/Atlas is exactly the kind of object the Galileo project was created to study. Multiple anomalies, unclear origin, potentially high significance, and enough public attention that investigating publicly won't get dismissed as fringe pseudoscience. Mainstream media is covering this. Governments are being asked questions. Scientists worldwide are observing. If Galileo project research reveals 3I/Atlas is natural, that's valuable. We learn about exotic comet formation conditions, about interstellar chemistry, about how objects behave in extreme environments. If research reveals something else, something not easily explained naturally, that changes everything. That becomes the most important scientific discovery in human history. Either outcome justifies the effort. Now, let's talk about historical context because humanity has been here before. October 13th, 1917, the Fatima event. 70,000 witnesses reported seeing the sun dance in the sky. Photographs show crowds staring upward. Newspapers covered it. Secular journalists confirmed people saw something. What did they actually see? Hypotheses range from mass hallucination induced by religious expectation to atmospheric optical effects caused by dust or water vapor to actual anomalous phenomenon we can't explain. The event lasted roughly 10 minutes. Reports described the sun appearing to spin, change colors, plunge toward Earth before returning to normal position. Some witnesses reported feeling heat. Others described their wet clothes drying instantly. Physical effects accompanying the visual phenomenon. Mass hallucination struggles to explain physical effects. Hallucinations are subjective perceptual distortions. They don't dry wet clothes. They don't generate heat felt by thousands simultaneously. That suggests something physical occurred, some real event beyond group psychology. Atmospheric optics could explain some aspects. Sunlight refracting through ice crystals or water droplets can produce spectacular effects. Sun pillars, sundogs, halos. Dust in the atmosphere from volcanic activity or wildfires can make the sun appear to change color or move erratically. But these effects are typically brief, lasting seconds to minutes at most, and they don't produce the specific phenomena described, the sun appearing to detach from its position and plunge toward Earth. That's not an optical effect. That's either misperception of some other phenomenon or something genuinely anomalous. Alternative hypothesis, an unrecognized astronomical event. Was there a solar eclipse misremembered? No, astronomical records show no eclipse on that date. A bright comet or meteor? None were recorded. A low-altitude bolide exploding in atmosphere? Possible, but witnesses described the sun itself behaving strangely, not a separate object. The simplest explanation fitting all observations is that something happened in the atmosphere or in space nearby that produced unusual visual effects observed by tens of thousands of people simultaneously. What that something was remains unclear. Could it have been an object, a craft, something operating near Earth producing electromagnetic or plasma effects visible from the ground? Possible, but speculative. No physical evidence exists beyond eyewitness testimony and photographs of crowds. No material recovered. No instrumentation recorded anything unusual. We're left with a historical mystery, a mass-witnessed event defying easy explanation, embedded in religious context, commemorated annually for over a century. And now, 108 years later, an interstellar object reportedly produces Fibonacci-like pulses on the anniversary. Coincidence? Almost certainly. But it's a remarkable coincidence, the kind that makes pattern-seeking minds wonder. David Serrata's interpretation ventures into numerology and mysticism. He connects 3I/Atlas's rotation period to Methuselah's age. He links orbital mechanics to golden ratio relationships. He claims hidden planets exist at Fibonacci distances. These ideas fall outside mainstream science. They're not testable in the conventional sense. They rely on numeric relationships that could be coincidental or could reflect deeper patterns we don't yet understand. Mainstream scientists dismiss this as apophenia, seeing meaningful patterns in random data. Human brains evolved to recognize patterns. It's how we survive. But this ability produces false positives. We see faces in clouds, hear words in static, find conspiracies in coincidences. Numerology exploits this tendency. You can find numeric relationships in anything if you look hard enough. Multiply this by that, divide by something else, round to the nearest integer. Eventually, you'll find the number you're looking for. It doesn't mean the relationship is real or meaningful. It just means you search long enough. So when Serrata claims 3I/Atlas's rotation period encodes biblical ages and golden ratios, skepticism is warranted. But skepticism doesn't require dismissal. Maybe there's nothing to it. Maybe it's pattern-seeking in overdrive. Or maybe, just maybe, there are patterns in reality we don't fully understand yet. And sometimes those patterns appear in unexpected places, waiting for someone to notice. The 432 connection is particularly interesting. Serrata says he was told in a vision to add 432 days to October 19, 2024, yielding December 25, 2025. Visions as data sources are scientifically problematic. But the number 432 appears repeatedly in contexts unrelated to visions. Ancient Sumerian timekeeping used base 60 mathematics generating numbers like 432,000. Hindu cosmology describes yugas lasting 432,000 years. The Great Pyramid's dimensions encode 432 in multiple ratios. Musical tuning based on A equals 432 Hz was historically used before modern standardization to A equals 440 Hz. Whether these occurrences are coincidental or reflect some underlying mathematical harmony is debatable, but the recurrence suggests 432 might have significance beyond random chance. If December 25th turns out to be significant, if something happens with 3i/Atlas on Christmas Day, the 432 connection gains credibility. If nothing happens, it's forgotten, another failed prediction in a long history of apocalyptic timelines and prophetic calculations. We'll know soon. We're 65 days out. The clock is running. Now, let's consider what December actually looks like in terms of observations. By early December, 3i/Atlas will have emerged from behind the Sun. Ground-based telescopes worldwide will be able to track it nightly. Position measurements will refine orbital calculations. By mid-December, close approach to Earth occurs. Distance roughly 270 million kilometers. Not close enough for danger, but close enough for excellent observation. Large telescopes can study it in detail. Spectroscopy will reveal composition. Photometry will measure brightness variations, indicating rotation or outgassing changes. Imaging might resolve the nucleus directly if it's large enough and bright enough. Amateur astronomers with backyard telescopes should be able to see it as a faint fuzzy smudge, maybe magnitude 11 or 12, requiring dark skies and patience, but definitely accessible to serious amateurs. That means thousands of independent observers watching, photographing, measuring. If anything unusual happens, it won't go unnoticed. By Christmas Day, December 25th, if Sarada's timeline holds, 3i/Atlas will be in a specific geometric position relative to Earth. Someone with orbital calculation software can verify whether the angle matches Giza Pyramid slope. If it does, that's an interesting synchronicity. If it doesn't, Sarada's interpretation collapses. This is testable. We don't need to wait for ambiguous signs. We can calculate the geometry and check. And if the geometry does match, what then? Does that prove intent, that 3i/Atlas deliberately timed its arrival for this alignment? No, not by itself. You'd need additional evidence of artificial origin before geometric alignments become significant. Without that, it's just another number game. But combined with other anomalies, it becomes one more data point in a pattern demanding explanation. The Great Pyramid itself is worth discussing because it's been central to alternative theories for decades. Built roughly 4,500 years ago, it encodes remarkable mathematical relationships. The ratio of perimeter to height approximates 2 pi. The slope angle relates to the golden ratio. Internal passages align with stars. Whether these relationships were intentional, showing advanced astronomical and mathematical knowledge, or coincidental artifacts of construction methods, is debated. Mainstream Egyptology holds that the pyramid builders used simple geometry, ropes, right angles, standardized measuring rods. The mathematical relationships emerged from practical construction techniques, not esoteric knowledge. Alternative researchers argue the relationships are too precise for coincidence, suggesting the builders understood trigonometry, astronomy, and geometry at levels supposedly not achieved until much later. This debate is unlikely to resolve soon, but 3i/Atlas connecting to Giza adds another layer. If an interstellar object aligns geometrically with an ancient monument encoding unusual mathematical relationships, that's intriguing regardless of what you believe about the pyramid's origins. It suggests either the universe is very strange, full of meaningful coincidences, or something is communicating using mathematics and geometry as a universal language. Mathematics is the one language that should be comprehensible to any technological civilization. Physics is the same everywhere. 2 + 2 = 4 in any star system. Geometric relationships like the golden ratio appear universally in nature. If you wanted to signal intelligence to another species, you'd use mathematics, prime numbers, geometric constants, algebraic patterns that can occur naturally. The Fibonacci sequence fits this perfectly. It's a simple recursive pattern producing a number sequence generating the golden ratio. It appears in nature, but in specific contexts: spiral shells, plant growth patterns, galaxy arms. Finding it in light pulses from an interstellar object would be like finding a message saying, "We understand mathematics. We're not random. Pay attention." Did Sarita actually observe Fibonacci pulses? That's the critical question. If he did, if the observation is real and repeatable, that's extraordinary evidence demanding extraordinary investigation. If he misinterpreted data, saw patterns that weren't there, or made a mistake in analysis, the whole Fibonacci interpretation collapses. Independent verification is essential. Did other observers see the same pulses on October 13th? Did telescopes in different locations record the same pattern? If so, it's real. If not, it's likely an artifact of Sarita's specific observing setup or analysis method. As of now, I haven't seen independent confirmation of the Fibonacci pulses. Sarita published his claim. Others have discussed it. But I haven't seen reports from major observatories saying, "Yes, we saw it too." That absence is telling. It doesn't prove Sarita wrong. Maybe others weren't looking at the right time with the right instruments. But it means we should withhold judgment until more data emerges. If you've been watching this far, you're exactly the kind of person who needs to understand what's at stake here. This isn't just an astronomy story. This is potentially a turning point in human history. We're watching an object that might rewrite our understanding of our place in the universe. I need you to leave a comment right now. Tell me, do you think we're witnessing something genuinely anomalous? Or is this explainable naturally? Drop your thoughts below. And make absolutely certain you've hit that like button and subscribed, because the next 2 months are going to be crucial, and you'll want to stay updated as this unfolds. The broader philosophical question lurking beneath all this is, are we ready? If 3i/Atlas is revealed to be artificial, if it's a probe or spacecraft or technology from another civilization, is humanity prepared for that revelation? Psychologically, culturally, politically, are we equipped to handle first contact? History suggests maybe not. Human societies don't deal well with paradigm shifts. When Copernicus showed Earth orbits the Sun, religious authorities fought for decades against accepting heliocentrism. When Darwin proposed evolution, controversy persists generations later. When quantum mechanics revealed reality's probabilistic nature, even Einstein rejected aspects, saying God doesn't play dice. Each major shift in understanding triggers resistance. People cling to familiar frameworks. They reject evidence contradicting their worldview. They attack messengers delivering uncomfortable truths. First contact would be the ultimate paradigm shift. Everything we think we know about history, about humanity's uniqueness, about our future, gets recontextualized. We're not special. We're not alone. We're not the pinnacle of evolution or intelligence. We're just one species among potentially countless others, probably not even particularly advanced compared to whatever sent 3i/Atlas. That realization would humble us in ways we've never experienced collectively. Some would embrace it. Scientific curiosity and wonder at discovering we have cosmic neighbors. Others would fear it. Unknown intelligence with unknown intentions and capabilities beyond ours. Still others would deny it. Conspiracy theories about government hoaxes, elaborate deceptions, anything to avoid confronting the reality. Religious responses would vary dramatically. Some traditions would integrate extraterrestrial intelligence easily. God creates many worlds, many beings, no conflict with doctrine. Others would struggle. How does alien intelligence fit into creation narratives centered on Earth and humanity? Theological debates would intensify. Some would see aliens as demons, others as angels, still others as irrelevant to spiritual truth. Political responses would be equally fractured. Nations would compete to establish contact, to gain technological advantage, to position themselves favorably with hypothetical alien benefactors or threats. Military establishments would analyze defensive implications. Economic systems would react to uncertainty. Markets hate uncertainty. And in the short term, until more information emerged, uncertainty would reign. We'd know something is out there, but not what it wants, not what it can do, not whether it's interested in us or merely passing through. That ambiguity would be terrifying and exhilarating simultaneously. Think about what contact would mean practically. If 3I/Atlas is a probe, it's likely automated. Any civilization capable of sending objects across interstellar distances probably doesn't risk biological crew. Too slow, too dangerous. You send robots, autonomous systems that can function for centuries, gathering data, reporting back. Communication time to home system depends on distance. If origin is 100 light-years away, radio signals take 100 years to arrive. Two-way conversation is impossible. The probe operates independently, following programmed instructions, making decisions autonomously. It might not even be designed to contact native species directly. It might just observe, collect data, transmit back. We could be specimens in a cosmic study, cataloged and analyzed without ever interacting with the observers. That possibility is oddly unsettling, being studied without consent, without even knowing who's watching. Alternative scenario: the probe is designed for contact. It's waiting for us to demonstrate technological capability before revealing its nature. Maybe approaching it, signaling it, showing we've noticed it, that triggers a response. It transmits data, blueprints, greetings, warnings, offers, whatever its mission requires. First contact happens not with a ship landing on the White House lawn, but with a data dump from an automated probe passing through. We suddenly have access to information about who sent it, why, what they want, what else is out there. That knowledge transforms civilization overnight. Another scenario: it's not here for us at all. Earth is incidental. The probe is surveying the solar system, categorizing planets and moons, gathering samples, mapping magnetic fields. It noted Earth's biosphere in passing, logged our existence, and continued its mission unconcerned with whether we noticed. In centuries, its creators might review data, see we existed, file us under interesting but primitive, and move on. We'd never hear from them. 3I/Atlas would pass, vanish into the cosmos, leaving us wondering forever whether it was natural or artificial. Worst scenario: it's a weapon. Ancient civilizations seeded the galaxy with automated defense systems targeting emerging technological species. 3I/Atlas approaches, evaluates our technological level, determines we're approaching threshold capability, and initiates suppression protocols. This is the dark forest hypothesis. The galaxy is full of predators hiding in silence, and revealing yourself draws their attention. If true, 3I/Atlas detecting our radio transmissions might trigger a response we can't survive. This scenario is speculative and paranoid, but not impossible. We have no idea what's out there, what ethics or motivations might drive other civilizations. Assuming benevolence is hopeful but potentially naive. Most likely scenario: if 3I/Atlas is artificial, it's old and dormant. A probe launched millions of years ago by a civilization that might not even exist anymore. It's still functioning, still following ancient programming, but nobody's home anymore to receive its data. We're being observed by ghost technology, remnants of a long-dead culture. We might eventually decode information stored in its structure or transmissions, learning about extinct alien civilization, but never meeting them. That's bittersweet. Confirmation we're not alone, but also confirmation that intelligence doesn't necessarily endure. Even advanced civilizations die eventually. Let's consider the energetics of 3I/Atlas more carefully, because this reveals whether certain scenarios are physically plausible. The object is receiving 33 gigawatts of solar power at perihelion. That sounds like enormous energy, but spread over a 5-kilometer diameter surface. It's about 1,300 watts per square meter, comparable to sunlight intensity on Earth. Most of that energy goes into heating the surface, sublimating ice, driving out gassing. But if any portion is converted to other forms, electricity, propulsion, communication, you still have substantial power available. Imagine a solar-powered spacecraft with 33 gigawatts at its disposal. You could operate massive computational systems. You could transmit powerful signals. You could charge energy storage systems for later use when farther from the sun. You could run ion drives generating thrust for trajectory adjustments. 33 gigawatts is enough to do almost anything you wanted, especially if your technology is more efficient than ours. This level of available power means if 3I/Atlas wanted to communicate, if it wanted to maneuver, if it wanted to deploy subprobes, perihelion is the ideal moment. Maximum energy input. Optimal conditions for energy-intensive operations. And we're not watching. The Oberth maneuver physics are worth understanding because they're counterintuitive. When you change velocity deep in a gravity well, you get more energy change than the same velocity change in free space. This happens because kinetic energy scales with velocity squared. If you're moving at 50 kilometers per second and increase velocity by 1 kilometer per second, your kinetic energy increases by more than if you were moving at 10 kilometers per second and increased by the same 1 kilometer per second. The faster you're moving when you apply thrust, the more efficiently that thrust translates into orbital energy change. This is why spacecraft performing interplanetary missions use gravity assists. They dive close to a planet, whip around using gravity to increase speed, and fire thrusters at closest approach. That combination provides maximum trajectory change for minimum fuel. If 3I/Atlas wanted to redirect toward a specific target, say, Earth, the most efficient place to do it is perihelion when moving fastest through the sun's gravity well. A relatively small velocity change there produces large changes in final trajectory. Without that maneuver, 3I/Atlas flies past and continues out of the solar system. With it, a new orbit is established, possibly targeting specific planet or moon. We won't know if such maneuver occurred until November when 3I/Atlas emerges and we remeasure its position. If the trajectory still matches gravitational predictions, no maneuver happened. If deviations are detected, something changed during the hidden period. Natural forces could cause this. Asymmetric outgassing creating thrust. But if deviation is large and directed specifically toward a target, natural explanations become implausible. That would be strong evidence for artificial origin because natural processes don't create targeted trajectory changes. They create random or semi-random perturbations. Think about the implications if 3I/Atlas redirects toward Earth after perihelion. It doesn't necessarily mean threat. It could mean interest. The probe noticed our technological signatures and adjusted course for closer observation. It could mean opportunity. Earth has resources or conditions the probe is programmed to investigate. It could mean nothing sinister, just curiosity. But it would confirm intelligence and capability. Something noticed us, evaluated us, and changed course deliberately. That's first contact by any reasonable definition. And it gives us 50 to 60 days, roughly the time from late October perihelion to late December Earth approach, to prepare, to decide how to respond, to attempt communication or observation with everything we have. International coordination would be essential. No single nation has all the observing assets. NASA, ESA, Roscosmos, CNSA, all space agencies would need to share data, coordinate observations, pool resources. Private observatories, universities, amateur astronomers, everyone with a telescope needs to watch. The more eyes on this object, the more data collected, the better our chances of understanding what's happening. And if communication attempts are warranted, the scientific community needs to agree on protocols. Do we send radio signals? What frequency? What message? Or do we stay quiet, avoiding revealing more about ourselves than necessary until we understand what we're dealing with? The METI debate, messaging extraterrestrial intelligence, has been contentious for decades. Some argue we should actively broadcast our presence, increase chances of contact, accelerate potential benefits from communication with advanced civilizations. Others argue silence is safer. Broadcasting reveals our location and capabilities to unknown intelligences with unknown intentions. We might attract attention we can't handle. The debate remains unresolved because we've never faced actual decision before. But if 3I/Atlas shows signs of intelligence, the debate becomes urgent and practical. Do we message it? Risk is lower than broadcasting randomly into space because the object already knows we're here if it's been observing. But messaging might prompt response we're not prepared for. Radio telescopes like Arecibo, now decommissioned, and China's FAST telescope could transmit powerful signals 3i/Atlas could detect. Content would matter. Mathematical sequences proving intelligence. Information about Earth, coordinates, chemistry, basic facts about our civilization. Invitations for dialogue. Or maybe just simple acknowledgement. We see you, we know you're there. Depending on 3i/Atlas's distance and receiving capabilities, round-trip communication time in December would be light minutes to light hours. Signal reaches the object in minutes. If it responds immediately, we receive reply within an hour. Fast enough for something resembling conversation. Imagine receiving the first message from another intelligence. What would it say? Would it be comprehensible? Would they use mathematics we recognize, language structures we can decode, or something completely alien requiring years to interpret? The content of that first message, if it comes, would set the tone for everything that follows. Greeting and peaceful intentions, relief and hope, demands or warnings, fear and preparation, gibberish we can't decode, frustration and uncertainty, or maybe just data, coordinates, star charts, information about other civilizations, encyclopedia of galactic knowledge. That would be overwhelming, transformative, the beginning of humanity joining a cosmic community we never knew existed. But I'm getting ahead of things. We don't know yet that 3i/Atlas is artificial. We don't know if it will redirect. We don't know if December brings anything beyond an unusual comet making close approach before leaving forever. Speculation is easy. Evidence is hard. And we need to be disciplined about distinguishing between what we know, what we suspect, and what we hope or fear. What we know, 3i/Atlas, is an interstellar object exhibiting 8 documented anomalies. Trajectory arrival timing is statistically improbable. Mass is extraordinarily large. Chemistry shows unprecedented signatures. Dust properties are reversed. And timing places it at perihelion now, behind the sun where we can't observe. What we suspect, the anomalies might indicate artificial origin, or they might result from natural processes we don't fully understand. Delayed data release from NASA could be bureaucratic incompetence, deliberate obfuscation, or cautious science waiting for verification before going public. Sarita's Fibonacci observations might be real or might be observational artifacts. December might bring significant developments or nothing at all. What we hope, if this is first contact, it's peaceful. If it's natural, it teaches us something profound about the universe. If it's neither, at least it's given us opportunity to think seriously about these questions, to prepare intellectually and emotionally for possibilities we'd ignored. What we fear, if it's a threat, we're unprepared. If it's real contact and we handle it badly, we might miss the greatest opportunity in human history. If it's nothing and we've worked ourselves into unfounded panic, we look foolish and damage credibility of serious scientific inquiry into these questions. All of this exists in superposition right now. Schrodinger's probe, simultaneously natural and artificial, threatening and benign, significant and irrelevant until we observe it and collapse possibilities into a single reality. And that observation window opens in November, less than 2 weeks away. When 3i/Atlas emerges from behind the sun, when first telescopes reacquire it after weeks of invisibility, the first measurements will tell us so much. Is it where gravity predicts? Has it fragmented? Does it look the same as before? Those initial observations set the trajectory, literally and figuratively, for everything that follows. If it's unchanged, behaving predictably, continuing on its gravitational path, we breathe easier. Anomalies remain unexplained but not threatening. We have until March and Juno's flyby to gather more data. But if it's changed, if trajectories shifted, if new objects appear, if activity increases beyond expectations, then December becomes critical. We watch intensely, analyze everything, prepare for unknown contingencies. The scientific community is ready. Observing plans are already being coordinated. Major observatories have allocated telescope time for 3I/Atlas observations through early 2026. Data sharing protocols are established. Analysis tools are prepared. Whatever happens, we'll document it thoroughly. This might be the most extensively observed interstellar object in history simply because timing and technology aligned. We have capabilities now that didn't exist during Oumuamua's visit. More telescopes, better instruments, faster communication, larger collaborative networks. If 3I/Atlas has secrets, we'll find them. Public engagement is also unprecedented. Previous astronomical discoveries stayed largely within scientific circles. 3I/Atlas has captured broader imagination. People who never cared about astronomy are following this story. Social media amplifies every development. YouTube channels, podcasts, blogs, everyone's discussing it. That attention is double-edged. It increases awareness and funding for research. It also spreads misinformation and unfounded speculation. Separating signal from noise becomes crucial. Reliable sources, peer-reviewed papers, official agency statements, credible science communicators need to be prioritized over sensationalist claims and conspiracy theories. If you're still with me at this point, you're clearly invested in understanding what's really happening here. That's exactly the mindset we need. Curious but critical, open but not credulous. Comment below and tell me, what would first contact mean to you personally? How would it change your view of reality, of humanity's place in the cosmos? And if you haven't already, subscribe now, because I'll be covering every development as 3I/Atlas emerges in November and approaches in December. Hit that like button to make sure this critical information reaches as many people as possible. Share this with anyone who needs to understand what might be unfolding above our heads right now. Let me bring this back to the human element because ultimately, this isn't just about an object in space. It's about us. It's about how we respond to mystery, to the unknown, to possibilities that challenge everything we thought we understood. Throughout history, humanity has faced moments when the universe revealed itself to be larger, stranger, more complex than we imagined. Galileo's telescope showing moons orbiting Jupiter, proving not everything orbits Earth. Hubble's observations revealing countless galaxies beyond the Milky Way, expanding the cosmos immeasurably. Each revelation humbled us, expanded our perspective, forced us to reconsider our significance. If 3I/Atlas turns out to be natural, it still teaches us. We learn that interstellar space can produce objects defying our expectations. We learn that chemistry, physics, orbital mechanics can combine in ways our models didn't predict. We refine theories, update textbooks, expand understanding. That's how science progresses. Anomalies drive discovery. If it's artificial, the lesson is far more profound. We learn we're not alone. We learn intelligence arises elsewhere, that technology can survive interstellar voyages, that someone cared enough about this region of space to send something here. We learn, perhaps, that the galaxy is populated, that civilizations communicate or at least observe one another, that humanity is entering a larger community we didn't know existed. Either outcome is valuable. Either advances human knowledge significantly. And that's why this matters, why you should care, why the next 2 months deserve your attention. We're living through potential history. Future generations might look back at late 2025 as the moment everything changed, the moment we first confirmed we're not alone. Or they might remember it as the year an unusually weird comet passed through and taught us interesting astrophysics. Either way, it's worth watching, worth understanding, worth participating in however you can, sharing information, supporting research, staying informed, thinking critically. The night sky has always inspired wonder. Ancient humans looked up and saw gods, heroes, eternal patterns governing fate and fortune. Modern humans look up and see physics, chemistry, distant worlds governed by laws we can understand and predict. Both perspectives hold truth. The sky is physics, atoms and energy and gravity. It's also mystery, the vastness of space, the possibility of other minds contemplating the same stars from unimaginable distances. 3i/Atlas is both. It's an object we can measure and analyze. It's also a question mark, a cosmic maybe, a possibility that won't resolve until we've gathered every bit of data we can. So as October ends and November begins, as 3i/Atlas emerges from its hiding place behind the sun, I encourage you to look up. Maybe grab binoculars or a telescope if you have access. Try to spot it. Participate in citizen science projects tracking it. Read the papers being published. Follow credible sources. Engage with this unfolding story. Because whether it's a comet or something more, it's ours to witness, ours to understand, ours to remember as the moment when possibilities expanded and the universe showed us something we'd never seen before. Thank you for making it all the way to the end of this journey through the mysteries of 3i/Atlas. If you're here right now, you're part of a community that values truth, that seeks understanding, that's willing to confront uncomfortable possibilities instead of hiding behind comfortable assumptions. Leave a comment right now and let me know. Write Fibonacci if you believe there's something genuinely anomalous about this object that deserves serious investigation. That one word tells me you've been paying attention, that you understand what's at stake. Make sure that like button is lit up. Your engagement determines how many others learn about this. And watch the next video that's appearing on your screen right now because this story is far from over. The emergence is coming. December is approaching. And whatever happens next, we'll be watching together. Thank you for joining me, and I'll see you in the next video.